Welcome to the SI Academy. Today we will discussing about the last topic of this chapter, corrosion. So corrosion, here we have learnt the following about corrosion in chapter 1. We already studied that the topics of corrosion in our first chapter earlier. So here silver articles becomes black after some time when exposed to the air. So why silver articles becomes black color in exposed to the air means because of that. Because why means silver, this is because it react with sulfur in air to form a coating of silver sulfide. Why silver articles becomes a black color when exposed to the air means, for that you write the answer. So silver is reacting with the sulfur in the air to form what? Silver sulfide. So this is why silver becomes what? Black in color. So here question arises here. First question. So why silver becomes black in color when exposed to the air means you can write. So silver is reacting with sulfur in the air to form what? Silver sulfide. Due to that reason only silver becomes what color here? Black color. This is what example of corrosion. Copper react with moist carbon dioxide. Here carbon is reacting with what? Moist carbon dioxide and in the air to slowly loses its shiny brown surface and gains a green coat. This green substance is called as what? Copper carbonate. Again that copper is reacting with the carbonate. So here copper is sorry, copper react with what? Moist carbon dioxide. Is copper reacting with what? Moist carbon dioxide in air. So it copper losing what? It's a shiny brown surface and gains what? Green coat. That gains what here? Green coat. That gains the what here? Green coat. So this is because of that what? That copper is reacting with the carbon dioxide. So due to that only that copper loses its shiny surface and gains the what color here? Green color. That why green color is formed due to the formation of what? Copper carbonate. Due to the formation of copper carbonate, copper is turning a shiny surface of brown to what? Green coat. So that turns what? Green coat. Next, which compound forms in that green coat means we can write basic copper carbonate, because of the basic copper carbonate only the green color will appears. Okay, next this is an example of what? Corrosion only. Iron when exposed to moist air. So iron is exposed to moist air for long time acquires a coating of brown flaky substance called as the rust. Okay, when iron is again exposed to the what? Air, so it will turn what color? So coating of browny black flaky substance are called as the sticker. This is a common example in our day-to-day life. That iron is exposed to that any moist air means that will converted into flaky substance, brown color flaky substance. So that is called as the what? Rusting of iron. This is the what? Examples of corrosion only. These are all first and second and third. These all points are examples of what? Corrosion only. The silver becomes what? Black because of the they are forming the what? Silver sulfide, and copper loses the shiny surface and becomes what? Green coat because of the formation of what? Copper carbonate, and here iron is get rusted and exposed to the air. These are all examples of what? Only corrosion property. Those are the examples of what? Corrosion only. Here activity 3.1, have to take three different test tubes. Okay, have to take three test tubes, and this is one A test tube, B test tube, and three test tubes. So in that first A test tube we are added the water and iron nail, and there is a air. Again in second test tube we are having the water, iron nails and water is there, and after the above water there is a layer of water, oil is there, and next that air also is there, and in that iron nail is there, and anhydrous calcium chloride. So that is what? Anhydrous calcium chloride is there, and that there is a dry air is there. So from this among the three test tubes, which one will shows the rusting of iron means, so we can say that easily that so that A test tube will shows the rusting of iron, because so in this condition, what is the condition of rusting of iron means, there should be what, air and water and metal. So these three condition means they definitely get the rusting. Here first case, here water is reacting with nail and that nail is also reacting with air. So air and water are reacting with the nail, so it will get rusted. So in the second test tube, the both air is there and water is there, but the B1 is not getting rusted, because here nail is reacting with the water, but the air and nail does not react with the the water and iron nail is reacting one another, but these two are not reacting with the air, because in between here oil is there. So that is why the B will not get rusted. So why B is not showing any rusting property? Because here iron nail is reacting with water, but it does not react with water air, because in between what there is, in between the oil is there, that prevent from the reacting of iron nail water to with what, air. So that is why they are not showing what, reaction with the air. So that is why it will not shows the any what, rusting property. In test tube there is no water is there and there is no air is there, so that is in this case it will be not rusting. Okay, in this case there is no rusting property will observed, but only in the case of A is observed, because there is a contact of both air and water, but in the B and C there is no contact of air and water, so it will not get rusted in the B test tube and C test tube. Only in A test tube iron will get rusted. That simple activity explained here. Activity 3.14, take a 3 test tubes and place clean iron nails in each of them. You have place 3 iron nails in them. Label these test tubes A and B. C. Pour some water in test tube A and cork it. This you have to make it cork close tightly. Again, pour boiled distilled water into test tube B and pour 1 ml of oil and cork it. This oil will float on the water and prevent the air from dissolving in the water. Again, the second test tube you have to add iron nail, water and oil. You have to add and you have to close that with the cork. Okay, and third one, to put some iron hydrous calcium chloride in test tube C and cork it, and iron hydrous calcium chloride will absorb the moisture, if any, from the air. So leaves these test tubes for a few days and then observe it. Okay, this third one is that's anhydrous calcium chloride will absorb the moisture if they are present in it, means so it will be completely absorbed by that anhydrous calcium chloride. So after 4 or 5 days or a week, so after that we have to observe which one will get the rusted in test tube A, test tube B and test tube C, means so we will definitely say that test tube A, or already we explained in above sections. Okay, you observe that the iron nails rust in test tube A, but they do not rust in test tube B and test tube C. In this test tube, all the nails are exposed to both air and water. In test tube B, the nails are exposed to only water and the nails in the test tube C are exposed to dry air. What does this tells about the condition under which iron particles rust? Okay, we already explained here what is the how it will be rusted, means we can say that only iron rust in the case of water. So iron get rust in the only in the case of water. There is a water and as well as the air, means that time only the iron will get rusted. In this A test tube both are contact within iron nail, but in test tube B and test tube C there is no such contact of water and air with the iron nail. So how iron get rusted, means only two condition. One is what, water is should be present and air also present, means definitely that iron particles are get rusted. This is the simple activity. So this activity explains here. So iron get rusted only in two condition. What is that? Is air and water. So this is the activity or activity what that 3.14. Next is how we already know that the every particles get water rusted means so how it will be prevented. So what are the prevention method of corrosion means the rusting of iron can be prevented by painting, oiling, greasing, galvanization, and chrome plating, anodizing, making alloys. These are the important methods to prevent the corrosion. What are the important methods, or write the methods of corrosion means write the prevention of corrosion method means you can write painting, oiling, greasing, galvanizing, chrome plating, and ironizing or making alloys. These are the examples of that prevention of corrosion method. Very important here. So which methods are used to prevent the corrosion means you can write painting, oiling, greasing, galvanizing, chrome plating, and anodizing or making alloys. These are the best method to prevent the what corrosion. These are the best methods, or these are the important methods to prevent the corrosion. Galvanization is a method of protecting such sorry, what is here another question comes here, what is galvanization means you can write galvanization is a method of protecting steel and iron. So what is galvanization method? It is a method of protecting steel and iron. It is the method of protecting steel and iron from rusting by water, coating with them with a thin layer of zinc. What is a galvanization method? One more question means you can write galvanization is a method of protecting iron and steel. So is coating with what zinc layer, so it's called as what galvanization. Very important one mark definition. What is galvanization means you can write galvanization is a method of protecting steel and iron from rusting by coating with what zinc layer. It will protect from iron and what and steel. So iron and steel with the layer of which layer, that is the zinc layer. So galvanization is a process of protecting iron and steel with a thin layer of with a thin layer of what zinc is called as what galvanization. So alloying is a very good method. So what is here next? Alloying. Alloying is a very good method of improving the properties of metals. We can just get the desired properties by this method. Okay, another method of alloying. So alloying means so again it will prevent from the rusting, and it is the good method that will give the best way of prevention of methods. Okay, so alloying is a what a combination of 2-3 metals that will use the different properties compared to their constituent metals. So that combining of 2 or more metals will gives the what some different properties. Constituent metals means which there are two metals combined, that called as what constituent metals. For example, iron is the most widely used metal. Here iron is what most widely used metal, but is never used in its pure state again. So iron is used widely, but it is not used in its pure state. So why means question comes here, why iron is not used in its pure state means this is because the pure iron is very soft and stretches easily when hot. Why pure iron is not used in its pure state means for that answer you can write so pure iron is a very soft and it stretches easily when hot. This is the reason we are not using pure iron in the pure iron in its state. Why iron is not used in pure state means write the answer for that question means pure iron is what very soft in its pure state. It is very soft in its pure state and stretches easily when it is hot. So due to that it will be prevented by what, it mixing with what here small amount of carbon about 0.05%, so it becomes hard and strong. So pure iron is not used in its pure iron is not used. Why means because these are very soft and it can easily be stretched when it is hotted. So if you can, then we are adding to it what carbon is we are adding to it in smaller portion, that 0.05%, so that after that adding carbon to it pure iron, so it will becomes very hard and strong, that we can using in commercial way. So in different ways, in a different commercial ways we can use the iron. So after adding with carbon, iron is mixed with nickel and chromium. Again, iron is what mixing with the nickel and chromium, we get a stainless steel. So again very important, so write the alloys of stainless steel. Question comes here, write the alloys of stainless steel means, so you can write iron is mixed with nickel and chromium, we get which type of alloy, that is called as the stainless steel, which is not, which is a hard and does not rust. This is the major major part that we are using stainless steel. Why means it is a very hard, again good thing, and it will not get rust. Because of that they are mixed with water, nickel and chromium iron. These three elements will combine to give what stainless steel. So iron is mixed with nickel and chromium, we will get stainless steel. The alloys of stainless steel are what iron, nickel, chromium. And what is this property of stainless steel means, it will not corrode and it having the hard structure or rigid structure. The iron is mixed with some other substance, it is its property change. In fact, the properties of any metal can be changed if it's mixed with some other substance. So iron is mixed with any other materials means that also changes its property, it will gives the new substance properties. So because there we are mixing with one another, okay, that is called as the alloying. So one or two elements are mixed with each other and gives that different properties. That type of method we can call that, that is called as the alloying. The substance added may be a metal or a non-metal. The substance we are allowing means that added metal should be metal or may non-metal also. There is not condition such like that. So maybe metal or a non-metal. So if maybe metal also, if non-metal also, there is no such like condition. Okay, we can mix with both metal as well as the non-metal. An alloy is a homogeneous mixture. Okay, an alloy, what again one more question comes here, what is alloy? So an alloy is a homogeneous mixture of two or more metals or non-metals and metals. Okay, what is alloy? One more question comes here, what is alloy means, alloy is a homogeneous mixture which is a mixture of two or more metals or metal and non-metal. So maybe metal also, metal and non-metal is called as what, homogeneous, is called as what, alloy. Here the term comes here, homogeneous. What is the meaning of homogeneous means, what we know that the definition of alloy, alloy is what, alloy is a homogeneous mixture of two or more metals or a metal and non-metal. So now you know that the alloy. But here what is the term here, homogeneous, homogeneous. Here term homo means what, same. The term homo means what, same. Genius, so what is meaning of the homogeneous means, the composition throughout is uniform. The compound is through the uniform composition is called as what, homogeneous. What is composition, what is, sorry, homogeneous means the composition is throughout uniform. The composition, whatever that composition of the element is what, uniform, is called as what, homogeneous mixture. We already studied in the ninth class that there are two types of solution is there. One is homogeneous and another one is what, heterogeneous solution. You know, you small, we'll recap that. So in ninth classes we studied that the two types of solution is there. One is the homogeneous solution, another one is called also heterogeneous solution. Homogeneous means the solution which is uniform composition throughout is called as homogeneous. What is heterogeneous means, the solutions which are not uniform composition are called as heterogeneous. These are a very simple concept we studied in its ninth class. Okay, so next, what is alloy means? Is an homogeneous mixture of two or more metals and non-metals is called as what? Alloy. It is prepared by first melting the primary metal and then dissolving the other elements in this definite proportion. It is then cooled at cooled to room temperature. How we can prepare the alloys means, you have to take two different types of elements, and first you have to make the first primary element melt. After that, secondary element is added in the primary element, so that will gives the what? Alloy. And after that, definite proportion you have to add it. After it cool down means you will get the what? Alloy. First you have to add a primary element, in that you have to add a secondary element. So after that, heating it, so it will be cooled down at room temperature, and finally we got the our required alloy. Depending on our requirement, we can add the metals and non-metals, and we can get the what? Alloy. This is the simple. Okay, and also very important. Pure gold is known as a 24 karat gold. It is very soft. It is therefore not suitable for making the what? Jewelry. So that is, we are adding in it to the what? Copper or what? Silver. Again, pure gold is, we cannot use it. Okay, because of they are very soft. So that is why we are adding what? Copper or silver. 2% of copper or silver is adding to what? 22 karat of gold, so that to make what? Good quality of strength, and we can make easily ornaments from that gold. Okay, here pure gold 24 karat is very soft. It is therefore not suitable for what? Making jewelry. It is allowed with either silver or copper to make hard. Generally in India, 22 karat gold is used for making ornaments. It means that 22 parts of your gold is already with the 2 parts of either copper or silver. Here 24 karat gold is not perfectly pure, because that contain 2% of copper or silver. So because of that, we can call that only 22% is 22 part of the 22 part is pure gold, and 2 part is what? Is either maybe silver or a copper, because that 2 part will make the silver. That 2 part maybe what? Copper or silver may makes the gold to good. We can make good strength, and that makes the what? Or depending makes the what? Ornament, depending on our need. Due to that adding of 2 parts of silver or copper, that makes the gold ornaments. We are not add the ornament, we are not adding the copper or silver, means it will not suitable for making what? Jewelry. So that is why, because that gold is very what? Smooth and soft, so we cannot create a ornaments with the gold. That is why we are adding 2% of copper or silver to it. So that is why we are having different kinds of ornaments, or we are all of you are wearing that because of that only. If one of the metal is mercury, then the alloy is known as what? Amalgam. Again, one more question comes here. What is amalgam? Means we can write one of the metal is mercury. One of the metal is mercury, then the alloy is known as what? Amalgam. If we are making the alloy, so one metal is taken as mercury, means that then that alloy formed is called as what? Amalgam. If you are making the alloy, first we have taken one metal as the mercury, remaining are maybe metal or non-metal, but that formed alloy always called as what? Amalgam. One mark definition is here. If the one of the metal is mercury, then the alloy is known as what? Amalgam. The electrical conductivity and melting point of alloy is less than that of its pure metals. Okay, here the electrical conductivity and melting point of an alloy is what? Less than the top of pure metals. What are that? Pure metals having high conductivity and a high melting point, but after the formation of alloy, the alloy having what? Very less conductivity and what a melting point compared to its pure metals. For that is same that properties, due to that properties only we are using what fuses in it. So these alloys are used in what fuses. If the high electric current it passes through, it means the first they will melt and the circuit will be prevented for further shock absorptions or further short circuit. Due to that only the alloys are used in what in fuses, because that alloy having what low conductivity and low melting point. Due to that reason only they are used in what electric fuses. For example, brass and alloy of copper and zinc. Again, very important. Note that. So, in example, in exams, it may be asked write the alloys or give the example. Means you can write alloy of copper and zinc. What is called as what brass. What is the alloy of brass? Means you can write copper and zinc are the alloy of brass. Again, like bronze. Bronze is an alloy of what copper and tin. So brass is an alloy of copper and zinc. Bronze is an alloy of what copper and tin are not good conductors of electricity, where copper is used as making electrical circuit. Here the brass and that bronze are a bad conductor of electricity, but the constituent of brass and bronze is what copper. So the copper is what good conductor of electricity. So that is why I am saying that copper is having a conduction property, but brass and bronze having what bad conductor. This is called as the what different properties compared to their its constituent. The brass constituent and bronze constituent is what one of them is copper. So copper property is what to conduct the electricity, but here brass and bronze are not are what not good conductor or bad conductor. So that is the difference between metal and alloy. That alloy what shows different properties compared to their what constituent properties. Solder, an alloy of an lead and tin. Again, that solder is an again alloy of what lead and tin, has a low melting point and used to welding electrical wires together. So in an electrician, that joining the capacitor, resistance, integrated chips, so diode, so that time they will use as what solder. That solder is used formed by which type of metals? That is the lead and tin, that will use the what solder alloy, that is formed by tin and lead. So that is used in what welding the electrical wires together. So these are the some important alloys that are very useful in modern days. Okay, so in example, in exams they are asked, means you can write these all alloys. Okay, very important, read. Okay, so thank you for watching, and please subscribe my channel and share with your friends and families. Okay, thank you for watching, and please subscribe my channel Desai Academy. Thank you for watching.